Today we're going to talk about half-life. So before we do that, go ahead and do the problem of the day, these three problems right here. Um, so pause the video. When you're done, you can unpause the video to check your work. So for number one, it says if $7,000 is invested at 5% annual interest compounded monthly, when will the investment be worth 8,500? So we're talking about compounding interest. And remember when we said we are compounding interest, we're using the formula A is equal to P times 1 plus R over N to the NT power. And so in this case, it says $7,000 is invested, so that's your P, at 5% interest rate. Oops, sorry, not equals. That's your P. At 5% interest rate, so 1 plus 0.05 compounded monthly. Monthly means your end value is 12. So this was 12, and it says when will the investment be worth 8,500? So we don't know the time, but we do know the amount is 8,500. So remember when you're solving this, you want to do PEMDAS backwards. And so we want to get rid of things that are added or subtracted to the base with the exponent, because remember, exponent in parentheses are at the end. So that means we need to get rid of that 7,000 first. And so when I do that, 8,500 divided by 7,000 gives us this fraction 17 over 14, because we want to make this as exact as possible, equals 1 plus 0.05 divided by 12 to the 12 times time. And so now I have a base with an exponent. We didn't have any multiplication or division on the, or sorry, we didn't have any addition or subtraction. We had multiplication or division. So remember, in order to solve for variable exponents, how do we do that? We use logarithms. So this would be the log, and the base is 1 plus 0.05 divided by 12. And then the argument is 17 over 14 is equal to 12t, and then the last step would be to divide both sides by 12. So then in your calculator, when you plug this in, remember you can go to math, log base. If you don't have the log base, you can use a change base formula. So 1 plus 0.05 divided by 12, and that argument was 17 divided by 14, enter, and of course divide that by the 12 because it was 12t. And that gives us 3.89 years. Because again, we had to divide both sides by this 12 here. So t equals 3.89 years. Looking at the next one, if you invest $3,500 at 3% annual interest compounded continuously, those are keywords to help us figure out that we're using A equals PE to the RT power. How much is in the account at the end of 4 years? So we were trying to figure out A. We don't know what the value of that is. Our initial amount is 3,500. E is just the number E in your calculator. You're going to use that because remember it's 2.71, etc. So we have 0.03, sorry, that's a decimal, times 4 years, and then we're just plugging that in. So in my calculator, I go to 3,500, and then second division symbol gives me the E to the power of 0.03 times 4, and that's $3,946.24 when we round. So the last one might have been a little bit harder. So for this one it says, when tap water is filtered through a layer of charcoal and other purifying agents, 30% of the chemical impurities in the water are removed. If the water is filtered through a second purifying layer, 30% of the remaining impurities are removed. How many layers are needed to ensure that 95% of the impurities are removed? So this one did not talk about compounding anything monthly or daily. There's no compounding interest. It also does not talk about compounding continuously. So that means that we are not using one of those two formulas. Well, then what are we using? So for this one, this is actually something we're removing each time as a percentage. So this is actually exponential decay. So what's our exponential equation? Remember, y equals ab to the power of x. So recall that a is equal to the initial amount. So we've talked about that before. So in this case, what are you starting off with if you keep removing something by 30% each time and you want to ensure that 95% of the impurities are removed completely? Well, you start off with 100% of something, right? So 100%, which means we're going to use 1 because we want to use the decimal. B, remember, is going to be the decay factor. And we learned before to find b is equal to 1 plus your rate. So they gave us the rate at which we're decaying, which is 30%. So we know r is equal to negative 0.3. And so we're going to plug that in to find b. So b is equal to 1 minus 0.3, which means that b is 0.7, which makes sense for something that's exponential decay, because remember, decay means your b value is in between 0 and 1. So we have y is equal to 1, because that was our initial amount, 100%, times 0.7 to the x power. And so what else were we given in the equation? It says how many layers, so that means we're trying to solve for our x, which is the number of layers. So x is equal to the number of layers to be removed. And so for this, what is y equal to then? Y is going to be the amount remaining. So in this case, it says how many layers you need to ensure that 95% of the impurities are removed. So how much remains if 95% are removed? So that would be the 1, because we are starting off with 100%. So you're going to use the decimal. So 1 minus 0.95, or 100 minus 95 is 5%, or as a decimal, 0.05. So if it helps you to use 100 minus 95 and then change it to a decimal, that's fine. So then we can go ahead and take that y out and plug in 0.05. So again, we have another exponential equation that we're solving for. So we have this 1 times the 0.7 to the x power, which if we divide both sides by 1, it doesn't change the equation, so we don't really need to worry about that 1, so I'm just going to erase it out. So how do we solve for a variable exponent? Again, we use logarithms. So this is the log of 0.7, and the argument is 0.05 is equal to the exponent x. So then you can just plug that into your calculator to solve, to see that you get x is equal to 8.40. So if we're talking about removing a layer, we're not going to remove part of a layer, we're going to remove an entire layer. So that means we need to round to 9 layers. So that means 9 layers are needed. There are 9 layers, I should just say 9 layers need to be removed to ensure 95% of impurities are gone or removed, whatever you want to say. Okay, so that is the 3 different types of equations that we have already talked about and have been working with. So we just hadn't done too many of the exponential ones like we just did this last one. So that's why I wanted to put that in there, just to remind you that not every equation is going to be using compound equations. So keep that in mind. Some of them are going to be exponential growth or decay. And also this next part we're going to talk about, which is another equation, which is a half-life, which you've probably seen in your science classes. So the amount of radioactive substance that remains is given by the function A is equal to P times 0.5 to the x over h. And for this, A is the final amount, P is the initial amount of the substance, X equals 0 corresponds to the time when the radioactive decay or whatever it is that you're talking about began. And half-life of the substance is the H. And so for the first problem, it says, after a living organism dies, its carbon-14 decays exponentially. An archaeologist determines that the skeleton of a mastodon has lost 64% of its carbon-14. The half-life for carbon-14 is 5,730 years. Estimate how long ago the mastodon died. So again, we know that we are using the half-life formula because the key word right here, it says half-life. So A equals P times 0.5 to the X over H. And so in this case, P would be equal to, we're again determining that it has lost 64% of its carbon-14. So if you're talking about percentage of something, what do you start off with? Percentage of 100%, just like when we talked about the last problem. So that means P is 1. Our half-life it gave to us as 5,730 years. And we also are trying to find how long ago it died. So in this case, we're trying to find X. So that means we are given the amount. So again, it says an archaeologist determines that the skeleton of the mastodon has lost 64% of its carbon-14. So remember that A is the final amount. So if it's lost 64%, we want to figure out, well, how much is left? So 100% minus 64% gives us 36%. But again, remember you want to use the decimal for that. So 0.36. So in this case, we have 0.36 equals 1 times 0.5 to the power of x over our half-life, 5,730. So again, we're solving for a variable exponent. So the first thing you want to do is get the base with the exponent part isolated first. So we have 1 times all of this. So again, if you divide by 1, it's not going to change the equation, so I'm just going to erase that out. So now we have our exponential equation isolated. So now we can write this in log form to solve for the variable exponent. So this is the log, the base stays the base, 0.5, the argument's 0.36 is equal to the exponent, x over 5,730. So how do we solve for x? If you have something divided, that means you multiply both sides by 5,730. And those cancel out. So we get x is equal to, and then you can use your calculator. You can do it separately or just plug it in together. 5,730 times math, go to your log base. So log base of 0.5, and that was 0.36, enter. So we get 8,445, 0.6 years ago. Let's go ahead and round it to 2 decimals, so 8,445.63 years ago. So that's how long the mastodon died. So why don't you guys go ahead and do example 2 on your own, pause the video. When you're finished, you can unpause it to check your work. So example 2 says the isotope iodine-131 is used to treat some types of thyroid disease. Iodine-131 decays exponentially with a half-life, and again, those are your keywords to tell you you're using this formula, of 8.02 days. If the quantity of iodine-131 is administered to a patient, how long will it take for 99% of it to decay? So that's what we're looking for, is the time. So again, A equals P times 0.5 to the x over h. And so in this case, P, we start off with 100% again, so P is 1. Our half-life, it said, was 8.02 days. And the amount, we want 99% to decay, so 100% minus 99% is equal to 1%. or 0.01. And x is what we're trying to solve for. So 0.01 is equal to 1 times 0.5 to the x over 8.02. Again, 1 divided by anything doesn't change it, so we can erase that 1. So now we can go ahead and write this in log form. Log, the base is 0.5, the argument is 0.01. So log base 5 of 0.01 equals x over 8.02. Solve for x, multiply both sides by 8.02, and then plug that into your calculator, and you should have gotten 26.64 days. And that's it.